Hello everyone, this is Gursimran Singh. Welcome to the session of World Wide Web Security. WWW. The World Wide Web is one of the biggest inventions ever. It is also the biggest information resource of the world. It has opened floodgates of information and enables instant access to information anywhere, anytime and in any format. WWW is now contributing to the globalization of production and capital markets by reducing the cost of information and communication. The WWW has proved to be a producing ground for a large and growing number of e-business that carried out most of their sales and services over the internet. The World Wide Web is fundamentally a client-server application running over the internet and TCP IP intranets. Information stored on WWW is in the form of electronic documents called web pages. Now, web browser is used to access the information on World Wide Web. The new services are introduced every day: online banking, online transactions. It requires special security attention, but web presents new challenges not generally appreciated in the context of computer and network security. So, these are: the internet is two-way, unlike traditional publishing environment. Even electronic publishing system involving teletext, voice response or fax back. The web is vulnerable to attacks on the web servers over the internet. The web is increasingly serving as a highly visible outlet for corporate and product information and as the platform for business transactions. Reputations can be damaged and money can be lost if web servers are challenged. Although web servers are easy to use, web servers are relatively easy to configure and manage, and web content is increasingly easy to develop, and underlying software is extraordinarily complex. This complex software may hide many potential security flaws. The short history of the web is filled with the examples of new and upgraded systems properly installed that are vulnerable to a variety of security attacks. A web server can be exploited as a launching pad into corporations or agencies' computer complex. Once the web server is subverted, an attacker can able to gain access to data and systems not part of the web itself, but connected to the server at the local site. Now, casual and untrained users are common clients for web-based services, such as users are not necessarily aware of security risks that exist and do not have the tools or knowledge to take effective countermeasures. Now, let's discuss World Wide Web security threats. World Wide Web security threats can be grouped in terms of passive and active attacks. Passive attacks include eavesdropping on network traffic between browser and server and gaining access to information on a website that is supposed to be restricted. Active attacks include impersonating another users, altering message in transmission between client and server, and altering information on a website. Main WWW security threats can be briefed as integrity threats, confidentiality threats, authentication threats and denial of service attack. Now, we will discuss different threats with consequences and countermeasures. So, let us start our discussion with the first security threat, that is integrity threats. Data integrity means keeping the data intact. The main threats to data integrity on World Wide Web are modification of user data, Trojan horse browser, modification of memory, modification of message traffic in transmission. Now, the consequences of integrity threats are loss of information, compromise of machine, vulnerability to all other threats. Countermeasure of integrity threats is cryptographic checksums. Now, the second threat is confidentiality threat. The main threats to data confidentiality on World Wide Web are eavesdropping on the internet, theft of information from the server, theft of data from client and information about network configuration, information about which client talks to server. Now, consequences of confidentiality threats are loss of information and loss of privacy. Now, countermeasures are encryptions and web proxies. Now, next threat is authentication threat. The main threats to authentication on World Wide Web are impersonating of legal users and data forgery. Consequences of authentication threats are misrepresentation of user, belief that false information is valid. Now, countermeasures for authentication threats is use of cryptographic techniques. Now, next threat is, that is the most dangerous, denial of service attack. The main threat of denial of service attacks are killing of user threads, flooding machine with bogus requests, filling up disk or memory, isolating machine by DNS attacks. Consequences of denial of service attacks are disruptive, annoying, prevent users from getting work done. Now, countermeasures of denial of service, it is very difficult to prevent the denial of service attack. Now, there are certain web traffic security approaches that can provide web security. The various approaches that have been considered are similar in the service they provide and to some extent in the mechanism that they use, but they differ with respect to their scope and applications and their relative location within the TCP/IP protocol stack. Now, World Wide Web security can be provided on network layer, transport layer, application layer, and as well as by using the firewalls. Now, let's start our discussion with web security at network level. IP security is one way to provide web security on network layer. IP security is a collection of protocols designed by the Internet Engineering Task Force to provide security for a packet at network level. The advantage of using IP security is that it is transparent to end users and applications and provides a general purpose solution. Further, IP security includes a filtering capability so that only selected traffic need experience the overhead of IP security processing. The figure that is displayed on the screen represents the use of IP security to provide the World Wide Web security. IP security helps in creating authenticated and confidential packets for IP layer. IP security operates in two different modes, transparent mode and tunnel mode. So, in transport mode, IP security protects what is delivered from the transport layer to the network layer. In other words, transport mode protects the payload to be encapsulated in the network layer, as you can observe in the figure. Note that transport mode does not protect the whole IP header. It protects only the packet from the transport layer, the IP layer payload. In this mode, the IP security header and trailer are added to the information coming from the transport layer. The IP header is added later on, as you can observe in the figure. Transport mode is normally used when we need host to host protection of data. The sending host uses IP security to authenticate or encrypt the payload delivered from the transport layer. The receiving host uses IP security to check the authentication or decrypt the IP packet and deliver it to the above layer, that is transport layer. Now, the second mode is tunnel mode. In tunnel mode, IP security protects the entire packet. It takes an IP packet, includes the header, applies IP security methods to the entire packet and then adds a new IP header, as you can observe in the figure. The new IP header has different information than the original IP header. Tunnel mode is normally used between two routers, between a host and a router, or between a router and a host, as you can observe in the figure displayed. The entire original packet is protected from intrusion between the sender and the receiver, as if the whole packet goes through an imaginary tunnel. Now, if you will compare transport and tunnel mode, in transport mode, the IP security layer comes between the transport layer and the network layer. In tunnel mode, the flow is from network layer to the IP security layer and then back to the network layer again. As you can observe in the figure, it compares tunnel mode and transparent mode. Now, IP security defines two protocols, the authentication header protocol and encapsulating security payload ESP protocol to provide the authentication or encryption for packets at the IP level. We will discuss these protocols briefly here. Let's have a quick look on authentication header. First, the authentication header protocol is designed to authenticate the source code and to ensure the integrity of the payload carried in the IP packet. The protocol uses a hash function and symmetric key to create a message digest. The digest is inserted in the authentication header. The authentication header is then placed in the appropriate location based on the mode, whether it can be transport or tunnel mode. Figure shows the field and the positions of the authentication header in the transport mode. Now, encapsulating security payload, that is ESP. The AH protocols does not provide confidentiality, only source authentication and data integrity. IP security later defines an alternative protocol ESP that provides source authentication, integrity and confidentiality. ESP adds a header and trailer. Note that ESP's authentication data are added at the end of the packet, which make its calculation easier. As you can observe in the figure, location of ESP header and trailer. Now, let's discuss the second security approach, security at transport layer. Another relatively general purpose solution is to implement security just above the TCP. The primary example of this approach is SSL, that is Secure Socket Layer, and the follow on internet standard known as TLS, Transport Layer Security. At this level, there are two implementation choices. For full general SSL could be provided as the part of underlying protocol suite and therefore be transparent to applications. Alternatively, SSL can be embedded in specific packages. For example, Netscape, Microsoft Explorer browsers come with the SSL and most servers have implemented the protocol as represented in the figure, the implementation of SSL and TLS on transport layer. So, one of the goals of these protocols is to provide server and client authentication, data confidentiality and data integrity. Application layer client server programs such as HTTP, that is Hypertext Transfer Protocol, that uses the service of TCP can encapsulate their data in SSL packets. If the server and clients are capable of running SSL or TLS programs, then the client can use the URL HTTPS. It means Hypertext Transfer Protocol Secure instead of the HTTP, that is Hypertext Transfer Protocol, that allows HTTP message to be encapsulated in SSL packets. For example, credit card numbers can safely transferred via the internet for online shoppers. As you can observe in SSL define 4 protocols in 2 layers. The record protocol is the carrier. It carries messages from 3 other protocols as well as the data coming from the application layer. Messages from the record protocols are payload to the transport layer, normally TCP. The handshake protocol provides security parameters for record protocols. It establishes a cipher set and provides key and security parameters. It also authenticates the server to the client and the client to the server if it's required. The change cipher specification protocol is used for signaling the readiness of the cryptographic secrets. The last, the alert protocol, is used to report abnormal conditions. Now, let's discuss the security approach at the application layer, that is 7th layer in the OSI model. Application specific security services are embedded with the particular applications. The advantage of this approach is that service can be tailored to the specific need of given application. In the context of web security, an important example of this approach is Secure Electronic Transaction SET. As you can observe in the figure, examples of this architecture SET on the top of the HTTP. This is a common implementation. In some implementation, SET makes uses of TCP directly. Two protocols are used to provide security services for emails, that is electronic mails at application layer. Now, first one is Pretty Good Privacy, that is PGP, and Secure Multipurpose Internet Mail Extension, that is SMIME. Now, let us have a brief discussion on Secure Electronic Transaction. Now, SET is an open encryption and security specification designed to protect credit card transactions on the internet. The current version SET1 emerged from a call for security standards by MasterCard and Visa in Feb 1996. A wide range of companies were involved in developing the initial specifications, including Big Blues from the America, that is IBM, Microsoft, Netscape, RSA. Beginning in 1996, there have been numerous tests of concept, and by 1998 the first wave of SET compliant products was available. SET is not itself a payment system, rather it is a set of security protocols and formats that enables user to employ the existing credit card payment infrastructure on an open network such as the internet in a secure fashion. In essence, SET provides three services. First, it provides a secure communication channel among all parties involved in the transaction, provides trust by the use of X.509 version 3 digital certificates. It ensures privacy because the information is only available to parties in transaction when and where necessary. SET incorporates the following main features. Number 1, confidentiality of information. Cardholders' account and payment information is secure as it travels across the network. An interesting and important feature of SET is that it prevents the merchant from learning the cardholder's credit card number. This is only provided by the issuing bank. Conventional encryption by DES is used to provide confidentiality. Now, the second feature is integrity of data. Payment information sent from cardholders to merchants includes order information, personal data, and payment instructions. SET guarantees these messages contents are not altered in transmission. RSA, digital signature using SHA-1 hash codes providing message integrity. Certain messages are also protected by HMAC using SHA-1, that is secure hash algorithm. Now, the third feature is cardholders account authentication. SET enables merchants to verify that a cardholder is legal user of a valid card account number. SET uses X.509 version 3 digital certificates with RSA signatures for this purpose. Now, fourth feature is merchant authentication. SET enables cardholder to verify that a merchant has a relationship with the financial institution, allowing it to accept payment cards. SET uses X.509 version 3 digital certificates with RSA signature for this purpose. Note that unlike IP security and SSL TLS, SET provides only one choice for each cryptographic algorithm. This makes sense because SET is a single application with a single set of requirements, whereas IP security and SSL TLS are intended to support a range of applications. Email security at application layer can be provided by using PGP, that was invented by Phil Zimmermann to provide email with privacy, integrity, and authentication. PGP can be used to create a secure email messages. Another security service designed for electronic mail is Secure Multipurpose Internet Mail Extension. The protocol is an enhancement of Multipurpose Internet Mail Extension protocol. Now, let us discuss the next World Wide Web security approach that can be implemented in the form of firewalls. Now, firewall is bit different from previous World Wide Web security approaches because all previous security measures cannot prevent sender from sending the harmful messages to the system. To control access to system, we need firewalls. A firewall is a device, usually a router or a dedicated machine installed between the internal network of an organization and the rest of the internet. It is designed to forward some packets and filter out some others. You can observe the concept of the firewall from the figure displayed. A firewall may filter all incoming packets for a specific host or specific server such as HTTP. A firewall can be used to deny access to a specific host or a specific service in the organization. A firewall is usually classified as packet filter firewalls or a proxy based firewalls. First of all, we will discuss packet filter firewalls. A firewall can be used as a packet filter. It can forward or block packets based upon the information in the network layer and transport layer headers, that is source and destination IP address, source and destination port numbers and type of protocol used, that is TCP or UDP. A packet filter firewall can be a router that uses a filtering table to decide which packet must be discarded or which must be forwarded. Figure shows an example of filtering table for this kind of firewall. According to the figure, the following packets are filtered. Incoming packets from network 131.34.0.0 are blocked. Note that * means the entire network of 131.34.0.0.0 will be blocked. Incoming packets designated for any internal telnet server at port number 23 are blocked. Incoming packets designated for internal host 194.78.20.8 are blocked. The organization wants this host for internal use only. Outgoing packets designated for an HTTP sender at port number 80 are blocked. The organization does not want employees to browse the internet. Note that packet filtering firewalls can be divided into two categories: static and stateful firewalls. Static firewalls can be implemented using routers as discussed before, but stateful firewalls can effectively implemented as stand-alone firewall devices. Now the next category is proxy firewalls, the most advanced kind of packet filtering mechanisms ever. The packet filter firewall is based on the information available in the network and transport layer headers, that is IP address and port numbers. However, sometimes we need to filter a message based on the information available in the message itself, means at the application layer. As an example, assume that an organization wants to implement the following policies regarding its web page. Only those internet users who have previously established business relationship with the company can have access. Access to other users must be blocked. In this case, a packet filter firewall is not feasible because it cannot distinguish between different packets arriving at port number 80. Testing must be done at application level using the uniform resource locators. One solution is to install a proxy computer, sometimes called an application gateway also, which stands between the internal computer and the external computer. This machine acts as a server to client and client to server. The figure displayed shows an application gateway implementation for Hypertext Transfer Protocol (HTTP). When the client process sends the message, the application gateway runs a server process to receive the request. The server opens the packet at the application level and finds out if the request is legal. If it is, the server acts as a client process and sends the message to the real server in the external network. If it is not, the message is dropped and an error message is sent to the external user. In this way, the requests of the external users are filtered based on the contents at the application layer. So, in the conclusion, we can say as the dependency on World Wide Web is increasing and crucial information is being transferred on World Wide Web, the need of security is also increasing. We have different approaches to address the security issues of World Wide Web on network layer, transport layer and application layer, and we can use the firewalls also, but still user need to be very diligent while using the World Wide Web services. User awareness can protect him from many threats. So, stay protected and have a happy browsing. That's all for today's session. Thank you for watching. Thank you.